So, welcome to the Form 5 seminar lah. Okay. So, Form 5 okay. So in this case, you have received the notes, right? Okay. So, the QR code is answer lah, and also some other material. Okay. Basically, for this seminar, I teach Form 4, Chapter 6 Okay, Form 4, Chapter 6. Okay. So I do a bit of exit question and also, of course, more on the short questions. Okay. So, okay, think before that you can do a question for page page 16 first. Okay. Yeah, page 16 first. We do some question to warm up you first. Don't want to straight away enter the short part. Okay. So we do some the front part first, acid and alkali first. Then I teach you with more details about the short part. Okay. So standard solution. This one is remember the subtopic of 6.6 Okay, 6.6 Okay. So okay, in this question, standard solution of copper 2 nitrate is prepared through two methods. Okay. Diagram 7.1 shows the preparation of the standard solution. Calculate the value of Z. Okay, this one very simple one. Very simple one. Okay. So in this case, what I do is this one for standard solution, you got two methods. Okay, two methods. Okay, method one is called now, method what if you start with solid, right? What is the name called? What is the method called? Now, if you start with solid, then you add water, right? This is called weighing method. Remember, you weigh the mass first of how many copper 2, let's say copper 2 nitrate you use. Then you add water. Then you become this solution. Okay, from copper 2 nitrate solid to become solution. Okay, so if I ask you a very simple one, so they give you molar mass 188 okay? So they ask you how many gram. So I think very simple okay? And they give you number of mole 0.1 So I do is because number of mole equals to mass over molar mass So you just straight away, if you want to find mass, okay, very simple. Just mass of this copper nitrate equals to number of mole times molar mass. So just use 0.1 times the 188 Then you get like 18.8 gram. Like this. Okay. Then they ask you why these two solutions okay. Okay. Page 16 I'll do some questions to warm up first. Then we enter the short part. Okay. So they ask why blue color of these two solutions are different. By the way, just to tell you okay. Copper 2 nitrate solution they are blue color. Later on you see a lot of color. Okay. Then what happens now? Method 1 is weighing method Okay, weighing method Then method 2 is dilution. Dilution So what is dilution Dilution is add water. Okay. Now this one also add water. Okay, but this one dilution the purpose of them adding water is to do what? It's just to dilute the solution. It's just to decrease the concentration. Still remember? Okay, decrease the concentration. Okay, but inside actually you have more higher volume. Okay, then notice the concentration from 1.0 mole per dm cube decrease to 0.1 mole per dm cube. So this is the purpose okay, just to decrease the concentration. I mean, it's to another way to prepare a standard solution, but this one is to decrease. Okay, so you compare. So you can say compare then compare the intensity of blue color. Intensity increase decrease okay, decrease because you can say the concentration of Cu plus decrease because when you add more water, the blue color will get faded away Anything it's just like your maybe like your orange juice. If you add a lot of water, same thing lah. You add the orange is not so thick anymore lah. You become uh more dilute, more like watery. Okay. See okay. Which question I can do warm up first Okay. I think can then I do page 18 first. Page 18 Okay. So we also do some like neutralization first Okay, neutralization first. You can look at you can write down first what's the meaning of neutralization. Actually, like Form 4, Chapter 6 is very long, right? So that's why we do a bit of fun part first. Then we settle the mostly the short part at the back. So remember, neutralization means you need acid and alkali. The relation between acid and alkali, which will produce salt and water. Okay, so they ask, they give you like dental toothpaste. What is the purpose of this? How do toothpaste take care of your teeth? Take care of your tooth. Okay, so in this case, the toothpaste what happen? Because when you eat food, remember, when you eat food, inside contain a lot of acid. Correct lah. Okay, a lot of acid So which will cause your teeth to be broken. So that's why what I do is you use toothpaste because toothpaste basic. You can call it alkali, same thing. Okay, so like inside contain of like calcium hydroxide, all this stuff. Okay, so that this base what I do is this calcium hydroxide what they do, they react with the lactic acid inside your mouth. Okay, so to eliminate okay, all the bacteria inside. The bacteria basically will produce a lot of lactic acid. Can I? Any question? No. Okay. So um now you can look at the number one question. Okay, number one question. Okay, so in this case, let us example of sodium hydroxide, this dissolved in water. Okay, NaOH at the beginning is solid Now this one I told you just now the weighing method. Okay, weighing method. Dissolve in distilled water to prepare 100 cm cube, 0.5 mol per cube of this solution. pH value is 13.7 Okay. Calculate the mass of sodium hydroxide dissolved. Okay. So when they see mass, you have to remember, number of mole equals to mass over molar mass. Of course, the other one should be volume over molar volume. Then also the number of particles over Avogadro constant. So first of all, what I do is you find the best is you use this one in Malay one. Okay, so in this case, number of mole of NaOH lah. Okay, now they give you volume and they give you molarity. So you get one more formula you learn in Form 4, Chapter 6. Number of mole can be mv over 1000. So you got molarity, you got volume. Okay, this one remember all this you come out suddenly. Okay, so and like that to come out Form 4 Chapter 6. Okay, so equals to mv over 1000. You find the number of mole first, then you find the mass and then 0.5 times 100 over 1000. Then I think you get 0.05, right? Then you use mass, okay, mass. You use this formula, mass. If you want to find mass, what happen? Now, if you want to find mass, um, if you want to find mass, then you use number of mole multiply the molar mass, multiply molar mass, then you get equals to 0.05 times now NaOH so 23 plus 16 plus 1, then you get like 2.0 gram. Can. Then that's it lah. Okay, but I haven't finished lah because they say another sentence. Then the solution is diluted. Okay, diluted means just now I get this one Okay, then they say undergo dilution again Okay, undergo dilution again. So you produce a new solution. The new concentration of 0.1 okay, with the pH value of 13. So they ask the calculate the volume of distilled water that needs to be added. So this one a bit tricky lah. Okay, so what I do is now we find how to find the volume of. Okay, so notice this one is V1 the M1. Okay, before we start doing dilution Okay, then after that what happened? You got V1, you got M1. So then you have to find V2, right? How much? I mean, not V2 exactly, but you need to have V2 to find the volume of distilled water. So just remember just to recall, dilution, the formula is what? Dilution is, now they need to get this new one, new concentration. So this one is M2. Simple. You got this, okay? M1 V1 equals to M2 V2. Then what? Then your M1 is 0.5, V1 is 100, M2 is 0.1, V2 is you want to find. How much? So you just take this multiply, then you divide by 0.1. How much the one's answer? Yeah, 500 cm cube. So, but it's not the final answer. Okay. Because I don't want 500. Okay, I don't care about 500. I care about how much water I added. So at the beginning, remember what is M1 M1? M1 V1 means you before adding water before dilution. M2 V2 means after you add water So they said how much water needed to add. So you have to do what? You have to use 500 minus V2 minus V1. Okay, V2 minus V1. V2 minus V1. So 500 minus 100. So you get, this experiment you added 400 cm3 of water. This. Can. Let's see which question I do. Okay. Okay, this one. Okay. Show 3 pieces of page 19. Okay. We do a bit of acid and alkali to reminder. Okay. 3 cm of magnesium ribbon were inserted into 3 different type of acid with a concentration of 1.0 mole per m cube. Okay. So the table 4 shows the experimental result. Okay. So what happens inside, they have all the magnesium ribbon. Okay. Then they add 3 type of acid. A bit different. I mean, like, you don't know what acid yet. Okay, so in your opinion, why there are differences in the above observation for the reaction? Give suitable for acid P and R. Okay, so now which one has the most reactive reaction? You know, if you notice, obviously it's R, right? Notice R has the most reaction. Okay, then the least reaction is P, only got 5 bubble. Okay, let's say 5 bubble. This one let's say got 10 bubble. This one let's say got 20 bubble. Okay, so what happened? Okay, so in this case, you can say now you can just differentiate. Okay, so they say concentration same means the difference will be which type of acid you are using. Okay, which type of acid you are using. Okay, so um, what you can do is you can split or one is strong, one is weak, correct? So obviously stronger acid we have the stronger reaction okay, so normally R stronger P weak okay, but how about Q in the middle, how now isn't it not only strong and weak acid you can determine that, you also can determine by mono and diprotic, remember? So I give you an example okay. So what is the example for strong acid? Strong acid, remember? If the exam come up, you got like few okay. Strong acid got what? Okay, strong acid, you got HCl. You can give example or HNO3, hydrochloric acid, okay, nitric acid, and also the this one okay, obviously this one, and H2SO4. But H2SO4 is stronger. H2SO4 is diprotic acid. Diprotic. These two is mono. Both are strong acid, but diprotic is 2 times stronger because remember, H2SO4 produce 2 times the hydrogen ion compared to these two. Okay, then you got weak acid also. Okay, weak acid. Okay, weak acid, which will produce. I mean, which is the example of CH3COOH. Okay, or H3PO4. But H3PO4 is triprotic. Okay, you call it weak triprotic acid. This one answer. Or if they ask for the strong alkali, remember you got a few example. Then you got NaOH and also KOH. If you got weak alkali, what are the example? Weak alkali is ammonia. Remember NH3. So just to remind you, okay, even though they don't really come out alkali a lot okay. So in this case, you can say P is a weak acid. Okay, weak acid or you can say they ask why there are differences in the above observation. You can say it's a weak acid, or you can say P is ionizing partially in water. Okay, Q is a monoprotic acid. You can say monoprotic strong acid. Okay, the best answer You can say strong monoprotic acid. Okay, you can say I think the best one is that the strong monoprotic acid, which will ionize completely in water to produce 1 mole per dm cube of H plus. You can say like this. Okay. Q and R is strong, but R is, you can say that R is a strong diprotic acid. You can say a strong diprotic acid. Okay. Then ionizes completely in water to produce 2 mole per dm cube of H plus ions. If they want example, they ask suitable example of acid P and R. Acid P is weak acid is anything you can give. Okay, any weak acid you can give. CH3COOH, then the ethanoic acid, and also H3PO4, the phosphoric acid. Okay, and even the carbonic acid is accepted. But even though we not really learn in our syllabus, okay, but is accepted, the carbonic acid. Okay. Then R, you can give what? I can give the H2S4, okay, where you say produce 2 more per cube. Okay. Now if that's for Q, you can put HCl or HNO3. Nice lah. So if they compare three lah, okay, you can differentiate as weak, 1 weak lah, okay, weak acid. Then there are two is strong lah, but the middle one is strong monoprotic, and the right side is strong diprotic. Can I? Uh, hi, hi. Eh? Oh, hi, hi. I thought you went to sleep already. Okay. Can I finish? Okay, I think I don't want to waste too much time on here. Never problem. Okay, okay, no problem. No problem. Okay, I understand, understand. Sometime like that one online. Okay, so sometime okay, so you go back to page two lah. Okay, page two Okay, page two. So you enter the short part lah. Okay, don't want to stay too much on the acid and alkali. So all the meaning I think is simpler than this one lah. Okay, the back one is where you confuse that. So in this case just to remind, okay, most of you forgot already, of course, okay. So in order to do the questions, I think I have to remind again, okay. So what happen is we start with the solubility first. Of course, okay, if the ask what's the meaning of salt, okay. So if the ask what's the meaning of salt, right, you have to know lah, salt, okay. So remember is eh, remember the word, the keyword is the hydrogen ion, okay. It's an acid. Hydrogen ion from the acid will be replaced by the metal ion. So it becomes metal ion or the ammonium ion. Okay. So you can look back lah, that one. But you focus on the solubility first, because the meaning normally you memorize okay, by yourself. Okay. So either you forget lah. Okay. So you cannot that one. Then this one because meaning I put at the last one. Normally I put at the last because it's the die memorize Okay. But this one theory one, hopefully you can more remember lah. Okay. So in this case you got your sodium salt. Okay. Now remember this one Okay, the span salt the Na plus K plus, the NH4 plus, the NO3 minus. Okay. All these are soluble. Doesn't matter, remember? Doesn't matter meet with what salt, remember? Always soluble. Okay. This salt is always soluble. So, and the insoluble one is always this one. Okay. So CO3 2 negative, the carbonate salt, the oxide, the hydroxide. It's always insoluble. Cannot dissolve in water. Can Okay, no problem. Okay, then the Cl minus, remember? The Cl minus, yes, Cl minus, mostly soluble, yes. Okay, except these three. Except the three, So you got PbCl2, HgCl, HgCl, the lead 2 chloride, silver chloride, and mercury chloride. Okay, so remember this one. This is the way I memorize it. Except these three cannot. Uh, these three cannot dissolve, right? This better remember, okay? The PaH one. Okay. Then the one is also mostly soluble. Okay, except this three, remember? PbBaCa. The sulfate is PbBaCa. Okay, the basic one have to know lah. Okay. Remember the persatuan bahasa kimia, right? Okay. Have to memorize one. This one. Okay. So PbC PbC. Okay, PBC Eh, oh, can Then um we do a bit of a tricky lah. I mean the solubility, right? So remember for all the eh, for all the span salt have to take, right? Remember so you try very simple one, okay? Including the nitrate all take, right? Remember all the soluble salt, right? Very simple one, okay? And all the span salt. So I highlight nitrate just to remind again. Na plus, NH4 plus, K plus. Okay. So you just all take lah, is it? All the soluble all these soluble. Very simple. Okay. So and after that you got the COOH one. Okay, remember the COOH one. Okay. So there's a span all soluble mah. There's a COOH, the carbonate salt, oxide, hydroxide, all insoluble. Okay, insoluble. So they want to put cross, right? All the cross okay, all the cross. But notice there are some of them are thick, right? Now because the first prioritize is the span salt okay. Now carbonate salt there's an exception. Carbonate salt when you meet these three, you'll be soluble. 明白？don't give me Na2CO3 insoluble no Na2CO3 is soluble because the Na is the most important one. Okay, so you do all the cross. Okay, do all the cross. Can then the SO4 2 negative, right? Only got three is insoluble mah. Okay, mostly soluble, only got three lah. Okay, which is the SO4, right? The S. Okay, the SO4. Okay, so this one SO4. Okay, so you got PBC. So PB2 plus, C2 plus, Ba2 plus. Actually, Ag plus also insoluble lah. Just to tell you, okay? Silver sulfate is also insoluble, okay? Based on the research, okay? But normally in our syllabus, not really coming out a lot about Ag2SO4, but it is insoluble anyway, okay? So what I do is you put cross up. You put these three across, these four across. Others you put tick lah. Remember this one okay? So don't forget okay? Because later you use this to prepare salt, remember? Okay. Then the last one, Cl minus, Br minus, I minus. So this one also have an exception. Okay, where you have the peserta agama Hindu like Pb, Ag, Hg. This one, only these three are okay, where are insoluble. Okay, so Pb, Ag, Hg. Okay, then the Br minus, I minus, also same thing. They have the same with Cl minus. Then others you just put tick. Take. Can okay. Then you do then you try to do formula this one. Okay. So you try to take yourself this one. Whether soluble or insoluble. Give it like 1 minute. Can I? Okay. Very simple, right? Okay, so I'm sure you know that. Um, PB carbonate soluble, insoluble, sorry, insoluble. Na, you see Na, definitely soluble already. Okay. Then calcium sulfate, so like calcium sulfate, insoluble. Okay. Uh, silver nitrate soluble. Nitrate, notice nitrate all soluble. Nitrate, all the K, right? Soluble, soluble. FeCl3. Cl3 also most, Cl minus also mostly soluble. Soluble, soluble, soluble. Okay, a lot soluble one. So copper two sulfate is soluble. Calcium sulfate is insoluble. Don't confuse that. Okay. Then PbCl2. Okay. Then it's insoluble. Okay. The persatuan agama Hindu. Okay. It's insoluble. Then you got zinc carbonate. Carbonate, not soluble. Okay. Where there's no span. No span. Soluble. You see Na, nitrate, Na, soluble, soluble. AgCl is insoluble. Okay, so I hope lah, okay, by now you have the knowledge of this. Okay, PbSO4 insoluble, Pb nitrate soluble. Okay, nitrate ammonium ion soluble. This one insoluble. Okay, it's all the Na soluble. Okay, very simple one. Carbonate no. Okay, no K yes, NH4 yes, nitrate yes, carbonate no. Okay, so calcium chloride yes. Calcium only got three. I mean, chloride only got three. Pb, Ag, Hg, insoluble. Sulfate, PbBaCa, insoluble. K soluble. Carbonate, no. MgCl2, yes. Zinc sulfate, yes. Barium, yes lah. Carbonate, carbonate, no. NH4 plus, no. Yes. Nitrate, yes. MgSO4, yes. Carbonate, no. Zinc chloride, yes. Fe sulfate, yes. Iron 2 sulfate, yes. Then nitrate, yes. No problem, this one. Then you quickly move on to the other part there, where you prepare a one. Yeah, a bit reminder. Can I? Okay. So this one. Okay, I use this one. Remember? Page page 6. Okay, page 6. Later you do one question about this. Okay, page 6. Okay. So normally if they want to prepare, let's say prepare a sparse salt soluble sparse salt normally they don't come out anymore. Not to say anymore, but they rarely, barely come out. Okay, because this one is basically just a neutralization reaction, so they don't really come out. Okay, so because you just choose one acid and alkali. Like example, maybe I look at page 4 first. Okay, talk a bit first. Like if you want to prepare sparse salt, right? Let's say, sparse stand for what? Sparse stand for sodium ion, potassium ion, ammonium ion. So if you see any of these salt, right? So you just use neutralization, where H plus is your acid, okay? Then OH minus is your alkali. So like example, if I want to prepare NaCl, I just use shortcut, okay? NaCl, one is H plus, one is OH minus. That's simple, okay? Then uh, eh, the first chemical is the hydrochloric acid. You do cross, okay? Do shortcut, then you do cross. HCl. The second one is I use NaOH. That's it, okay? So you got HCl plus NaOH, you get NaCl, the most important thing, and you get H2O as a meaning of salt, okay? Actually produce salt and water. I mean, as a meaning of the neutralization, you produce salt and water. Okay, so example this one, all the procedure. Okay, all the procedure about the neutralization. Remember? Okay, so where you put the burette on top one, remember? Burette, you fill with acid. Okay, then On bottom, you fill it with the alkali, the NaOH. Okay. So the procedure later I'll tell you lah. I mean, not say later. I think you can try to read yourself lah later on. Okay. Basically, just same as your neutralization. Okay. So you have to pipette, of course lah. Some of the information, if you ask you to write the procedure, you have to write down the 25 cm cube, 2.0 more per lane cube. Okay. So the chances of them for Form 4 Chapter 6 come out essay that is quite high lah. Just to tell you because um eh, no battery. Give me a 3 second. So fast no battery already. So funny. I mean my laptop, not iPad. Laptop. Okay, good now. So fast no battery. Really funny. Okay. Okay, can I? Okay, so in this case, what do is now? You remember this alkali is have to put the phenolphthalein indicator lah. Put the phenolphthalein indicator and stroke that, remember? And then you add, then you put the burette, fill with acid, then you titrate that. When you titrate that, what happens is you let the acid slowly drop while you are do slowly. Means you're spinning the conical flask. Okay? You spin, then you slow. Okay? Then after that, until the pink color, because when you add phenolphthalein into the KOH, you will get a pink color solution. Then you titrate until you let the acid drop until the pink color turn to colorless. When it turn to colorless, okay, that's when the reaction is done. Now, but you have to repeat the experiment. Okay, so because I want to get a pure salt, I want to get a pure NaCl. I don't want any pink color. I don't want any phenolphthalein inside my salt. Okay, so that's why this time I have to repeat. This time with no phenolphthalein, no phenolphthalein. Okay, but how do I know how much volume do I need? How much volume of HCl do I need? That's why I reference to the first one. Let's say first one I use 25 cm. I open, then the second time, same thing, I just open 25 cm, then I stop. Now no need to see color because I already do the first time. Then I just put back with the same volume, same molarity. Then I will get the same result. Okay. Then what do we start? This one, remember? These steps. Okay. This step, because NaCl is whatever NaCl, KCl, yeah, they are soluble salt. Soluble salt means you cannot see the real insoluble salt, the solid. Okay, you cannot see the salt solid. So that's why you have to force them out in this experiment. Okay, you have to heat and cool so that you can see the salt crystal. Remember this fifth step. Okay, so you got heat, cool, filter, rinse, dry. Heat, cool, filter, rinse, dry. I mean, heat, cool, filter, rinse, dry. Heat, cool, filter, rinse, dry. Correct. Or you can memorize this way lah. Okay. Now heat is, remember the hippo. Hippo can fly really dangerous. These 5 steps right, have to remember. Okay. So if they ask you the right procedure, this one you have to write down. Okay. Hippo can fly really dangerous one. Okay. But of course lah, in exam you don't say the procedure heat what? Okay, you have to say lah. Okay. So the salt solution is heated you can say in an evaporating dish. Okay. The evaporating dish is just to make sure you can evaporate the extra water faster. Okay. Let's say I get KCl and H2O. I want to get a pure KCl. That's why I don't want water. I don't want any water, so I want to heat the water out to make sure the water evaporate out. Okay. Then you cool down. Okay, cool down, then you get the salt crystal. Then you try to try to filter because inside is still a bit of a water lah. So I filter with a filter. Then I rinse a bit because I want to get clean, clean salt, pure salt. Filter, then I rinse with the water, distilled water a few times. Then I use the filter paper to press to dry out the salt crystal. Okay. So any country is no. Okay. And also, let's say lah, okay, page 6. Now if I want to prepare a non-spa salt. Okay, soluble got two types. Okay, number one is using the neutralization. Number two is actually this one is also basically called a neutralization. Okay, but this one a bit of a different way lah. Okay, this one is using when you want to do non-spa salt. It means not sodium salt, not potassium salt, or not ammonium salt. So how do I do this? Now, example, let's say the soluble salt MgCl2. How do I prepare MgCl2? Okay, so very simple. First of all, exam they won't ask you, is to prepare. I mean, they won't give you this salt is soluble or insoluble. They give you this chemical, but they will not tell you is soluble or insoluble. So what I do is you split them. Okay, you ask yourself whether this salt is soluble or insoluble. Remember, chloride salt is always soluble. Okay, it's always soluble, only except when you got the PAH. Okay, the PbAgHg. Okay, so it's always soluble. If it is always soluble, then terbalik MgCl2 soluble, but you have to use insoluble to prepare. Like what? Remember the COO, which I told you earlier? The carbonate, oxide, hydroxide. Okay, and also this one you have to add an acid. Okay, so an acid. So the first reactant is HCl, the hydrochloric acid. HCl. Then what is the second reactant? Now the second reactant, it can be four of them. It can be Mg, carbonate, oxide, hydroxide. Okay, so let's say that I add MgCO3 as my reactant, okay, as my chemical. Okay, then I produce okay, MgCl2. Because Mg2 plus you find Cl minus 1. So you form MgCl2. Okay, then got your H2O and CO2. Okay, of course there are four different reactant can be used, but normally I recommend second and third one, the carbonate and the oxide. Okay, and carbonate and the oxide. Okay, so any question with this? You might ask, why copper cannot? Copper cannot, because based on the reactivity of metal that you learn copper is below H plus Copper below H plus means copper is less reactive than H plus. So if copper want to rampas away the H, very difficult. Okay, I mean, not rampas the H, but copper rampas the NO3 to form copper to nitrate, very difficult. So that's why H can keep the NO3, so there's no reaction. So any question? Any question this? Okay. So but the procedure is like this. Okay, procedure. Now, you pour 20 cm cube and 2.0 mol per liter. Okay, you pour nitric acid. Either okay, if you prepare nitrate normally you use nitric acid If you prepare Cl, normally you use hydrochloric acid. If you prepare sulfate, what happens? Let's say prepare magnesium sulfate. If you prepare sulfate, then you use sulfuric acid, the H2SO4. Just a bit of trick okay. Then what happens is you put inside the use this amount of acid, you put inside the beaker, then you heat the acid, then you add the copper 2 oxide powder. All these all these are solid powder. Okay, I just add powder. Okay, you stir until the solid no longer dissolve into the acid. No longer dissolve into the acid means all the all the acid has been used up. All the acid has 100% used up or reacted with the solid. Okay, so if you no more acid inside, then you get a lot of extra salt, excess copper 2 oxide, which you don't want. Okay, because you form the copper 2 nitrate. Okay, I don't want this extra powder, so I will filter the excess powder out, the extra powder, and the extra copper 2 oxide out. Okay, to get a pure copper 2 nitrate. Then after, of course, okay, because again, this one is soluble, so that's why you have to repeat these 3 steps. I mean, these 5 steps. Okay, which the heat, cool, filter, rinse, dry. Okay, so you have to heat, cool, filter, rinse, dry. Can but no later we'll write our procedure. Okay, any question this? No answer. Okay, so I explain one more about the insoluble salt. Then we'll do exercise for this first. Okay. So in this case, insoluble salt, you must prepare soluble salt. I use insoluble salt. One acid, one COOH. Simple, right? Okay. So I use all the like this. HCl, right? Acid, right? I can react with metal carbonate, metal oxide, metal hydroxide. Okay. So acid can react with these 4 things. Then how about this? This how? Let's say I want to prepare uh PbCl2. PbCl2. Okay. How do I prepare? You ask yourself, is PbCl2 soluble or insoluble? PbCl2 is uh, insoluble. Cannot dissolve in water. So if you cannot dissolve in water, terbalik theory, use insoluble, use soluble salt to prepare. Soluble salt always soluble one like span, remember? Lesson 1, span. Okay. So number 1, let's say that you use sodium chloride. So sodium chloride as your reactant. Second, lead-2 nitrate to prepare. Okay. So you get your NaNO3. Okay, Na you find NO3, Pb you find Pp you find Cl2, Cl minus. Instantly you get your insoluble salt. Okay, so remember this one. Okay, you must follow this theory. Okay, PbCl2. Like this, if I want to prepare BaSO4, I use span. Okay, so I use sodium sulfate or even K2SO4 possible, or ammonium. No, normally I don't recommend ammonium because ammonium is very active. Okay, I mean also reactive and reactive because ammonium is a bit hard to remember. Okay, so to prepare insoluble salt is called double decomposition reaction. Okay, so you just what do is you add you add 2 soluble salt together, mix together. Okay, then you stir the mixture, but you no need to heat and cool. You just filter, rinse, dry. Okay, and you can try this. I let you do exercise first. Wait. Uh, okay, so you move on to page 17 first. You write down okay, look at page, look at okay. Eh, is it this one? Or is it I got the better one? Okay, wait, you can write down this. Okay, wait. Oh, I write the better one. Wait, is it I got a better procedure? Wait. No. Wait, search a bit. Okay, so I think you can. Wait, where is it? Ah, so you can write out. Don't write this way lah. Okay, don't write this way. Okay, I think you don't write this way lah. Now, in 7 marks, right, you follow the procedure on the notes. Then you can try to write down your own first. Okay, I give you 5 minutes. And I give you 5 minutes. Don't follow the procedure that I showed just now. Okay, write down the before. Right. Okay, I'll be back soon. Yes. So I'm back. I'm back. Hi. Okay. So okay, I ask you lah. Okay, how to prepare zinc sulfate? They ask to prepare zinc sulfate lah. Okay. So not sure if you can write down your own. Now, zinc sulfate what happen? Okay, zinc sulfate is ZnSO4. Right? This one page 17 Okay. So ask yourself is zinc sulfate soluble? No, right? Okay. Zinc sulfate is sulfate is zinc sulfate is soluble. Sorry. Zinc sulfate is soluble. Okay. Sulfate only got three insoluble PBBSA. Okay. So Zn is soluble. Soluble means you use what to prepare? You use insoluble to prepare, like COOH and the acid. So ask yourself first. Then you can write down the procedure. You know what chemical, they can write down the procedure. So the first is, what is this? H plus and SO4 2 negative. So the first one is, they given you H2SO4, sulfuric acid. So you have to use this. Then second one, what you do? Zinc, zinc carbonate. Okay, zinc carbonate. Okay. Now, notice either it can be zinc solid, zinc carbonate, zinc oxide, or zinc hydroxide. Do I have any of this? No. Okay, I don't have any of this. So how? Now, if I don't have any of this, what I could do is now I could prepare myself. Okay. So let's basically if I ask, is it I should prepare zinc or I should prepare zinc carbonate? I should prepare zinc oxide. I should prepare zinc hydroxide. Then you ask the file, notice they give you two more. Right? What do you think you get if you add them together? Like this, zinc and carbonate. Isn't it you get zinc carbonate? When you add these two together, now, isn't the first step? The first step you have to do is, we have to not prepare zinc sulfate first. First step is to prepare the zinc carbonate first. Okay, zinc carbonate first. Then what you do is, this one is zinc carbonate is insoluble, carbonate is insoluble. Then you prepare, you using sponge salt, soluble salt to prepare. Then the first step is, you get sodium, okay? You get sodium carbonate, sodium carbonate. Then the second step is, I got zinc nitrate. This one very tricky. Okay, this one you have to prepare 2 times because sometimes exam like this one. Okay, like this exam they won't give you direct lah. Okay, so use these two add together to prepare zinc carbonate. Then I take the zinc carbonate add into the acid. Then only you can get zinc sulfate. Okay. So on for how to write the procedure. Okay, I'll show you lah. Okay, I'll show you Okay, so number one. Okay, I can use 50 cm cube. Okay, of now you have to mention okay. So you have to mention, let's say I want to prepare sodium carbonate first. I want to prepare zinc nitrate first, then add together. Okay, so you can say 50 cm cube of 1.0 mole per dm cube. Sodium carbonate solution in a liquid okay, carbonate sodium carbonate solution. Okay, so is added because you add these two okay, so it's added to another one okay, another one. This one you got sodium carbonate, okay, and zinc nitrate. Same thing right, same thing. Or 50 cm cube of 1.0 mole per dm cube. But this one is zinc nitrate solution. See? Like this. Okay? The proper sentence. And number two, how? The mixture. You have to stir, right? When you put inside the same beaker, you have to stir. Then the mixture is stir. Stir with glass rod. With glass rod. Okay. Then after that you get the zinc carbonate. What you do? Now for insoluble salt, you get zinc carbonate, you just straight away What you do? You filter Okay, you filter Okay, because zinc carbonate is insoluble Insoluble means you can get a white color powder, white color solid. Then you no need to heat cool. Okay, you just straight away. You straight away just filter the white color salt. Okay, so you can say filter the mixture to obtain the salt crystal form. Okay, basically, if you want the equation, right? So what happens? Let's say you scared, okay, you want to, let's say you want, maybe sometime they also might give mark on the equation, okay, so you just 含 down, okay, everything just 含 down, okay, so just put everything inside, so you got zinc nitrate plus sodium carbonate arrow, so zinc you find carbonate, Zn2 plus you find CO3 2 negative, then Na you find NO3. And then you balance the equation. Na you got 2, NO3 you got 2, then you multiply 2. Then I do the third step. Okay, third step. I get the salt crystal, I get the zinc carbonate. Now I add to what? I add to sulfuric acid. Okay, so you can say rinse the salt crystal formed. Okay, so rinse. Okay, the salt crystal form is zinc carbonate. Zinc carbonate. Okay, there's a third one. Okay, zinc carbonate means you get this one. Okay, zinc carbonate. This one you don't care. Okay, I want to filter out from here. Okay, I want to filter out. I will get the zinc carbonate. The fourth one. Now the fourth one. Finally, I do what? I add 50 cm cube of you use a standard one. Okay, 50 cm cube. 100 cm cube. Okay, proper one. Okay, 20 cm cube okay. Okay, so you don't add that only 5 cm cube. Don't, okay, you don't add all 5 cm cube like this. 1 cm cube okay, like this. Of course you don't want. Okay, how can you see the reaction? How can you get a salt? Okay, so you use a proper number. Okay, proper number. Suitable amount. Okay, 550, 100. Like this. Better. Okay, so even the molarity you don't put like uh, uh, 10 molybdenum cube. No lah, okay? Or you don't put like 0.0001. No need lah. Okay, you just put standard 1 molybdenum cube in exam. Okay, so you put this amount, sulfuric acid, sulfuric acid is pour into a beaker. Then now 5. Okay, just now you get the zinc carbonate. No, know if it was space or not. Okay, zinc carbonate crystal. Okay, is added bit by bit. Bit by bit. Okay. So when you heat the acid, then you put inside the beaker, you heat the acid, then you use a spoon, use a spatula, scoop some of the zinc carbonate, then you pour. Not everything just pour it one time. So you slowly add, okay? So bit by bit to the heated acid. Okay. Also need to stir while stirring. Use the uh, use your glass rod to stir. Okay. Stirring with glass rod. Okay, stirring with glass rod until remember you pour until one point where you stop. Until the powder cannot dissolve anymore. Okay. So number 6, the unreacted powder is Because you got the excess zinc carbonate add just now. Okay, I don't want to stick with together with this one, so I want to remove the extra one. I want to remove the extra one, so it's remove by filtration. Okay, and then 7. They want the other three side, right? Because you get the soluble zinc sulfate. So what I do, if you get a soluble salt, then what I do is the filtrate. The filtrate means talking about the zinc sulfate. Now remember the 5 steps at the back: heat, cool, filter, rinse, dry. Okay, so the hippo can fly really dangerous one. Okay, so filter is heated. Heated. Heated in and what? You call it in an evaporating dish. In an evaporating dish. Okay, until 1/3 of its original volume to obtain a saturated solution. Means you get the salt crystal lah. Salt crystal with the water. You can call it saturated solution. Okay, and then number 8, what to do? When you heat, then you need to cool down, right? Okay, so the hot saturated solution is allowed to cool. Allowed to cool, okay? Cool for crystallization to occur. Means to crystallization means where phase where your solid finally the purple color, blue color, purple color salt you produce. Okay. Then last one, and the crystal form. Remember you talk about heat cool, right? Heat cool. Then you have to say uh then the salt crystal are filter out, filter out, rinse with a little distilled water, and dry between sheets of filter paper. 来点咯。Okay, then the last equation okay, should be uh the zinc carbonate added into H2SO4 produce zinc sulfate. Because carbon definitely you have carbon dioxide. Okay, so the equation so you got H2O of course and CO2. So maybe exam 10 marks very easy one. Essay they come out 10 marks. At least. So this the I got a point okay how to write the procedure properly. So if this year come out this one if you memorize already or very easy one. Okay. Can so can any question this then I move on to the other part already. So this is the how to prepare salt. I got the procedure how to write. Okay. Maybe okay. Maybe. Okay. The key point is this one is a bit tricky question. Okay. So you have to prepare 2 times. prepare the on top one. Okay, 1 to 3. Okay, 1 to 3. Wait, I write for you. 1 to 3. That one is to prepare the insoluble salt first. Okay, then the other part, all this are prepare the soluble salt. Like this, a bit tricky. Can done. I know a lot of things, correct? Okay. Done. Okay, good. Okay, good. Okay, so I think we move on to the other part. Okay, the other part. Okay, so you look at page 10. Okay, just to remind the color of salt. Move on to color. Just now we talk about solubility. Okay, we talk about the uh prepared salt. And now we talk about a bit of a color salt, color of salt. Okay, now just to remind. Okay, color. Okay, so just to remind you. So for copper 2 ion. Remember copper 2 ion? Okay, a lot of people still forget one. Okay, copper 2 ion. Okay, so copper 2 ion. The salt, right? Mostly blue color. When you dissolve in water, blue color. Okay, but certain one cannot dissolve one, like copper 2 carbonate. Okay, copper 2 carbonate is green color. Remember, copper 2 carbonate is green color. Okay, green color. But mostly green. Okay, green. Write down green. Okay, and also copper 2 chloride. Solid is green color. Okay, solid green color. Okay, but for other like copper 2 sulfate, copper 2 sulfate, remember, copper 2 sulfate, copper 2 nitrate, copper 2 hydroxide, all these are blue color. Okay, or even copper 2 chloride, when you dissolve in water in liquid, in aqueous, so also blue color. Yeah, just remember lah. Okay, just to remind you. So mostly if can dissolve in water, mostly it's blue color. Okay. The only black color. Okay, I think student most remember lah. The only black color is copper 2 oxide. Copper 2 oxide. So can. I'm sure no problem. Can differentiate son. Okay. Then Fe2 plus doesn't matter if pair with carbonate, chloride, sulfate, nitrate, hydroxide, oxide, green color. Green color. Fe3 plus, remember even if learn in Form 5 Chapter 1, talking about the rusting of iron. So rusted is brown color. Okay, doesn't matter. Pair with what? Negative ions. Okay. Uh, if I didn't mention any other salt, other like magnesium sulfate, didn't mention calcium chloride, all these are white color. Okay, white color. When you dissolve in water, become colorless solution. Okay. And the special salt, of course, I had to mention. Okay, the special salt, like PBO. Remember the peanut one? Okay, peanut. Brown color when hot. This one special one. Okay, remember? Important. Okay, important. So brown and hot. Then yellow when cold. This one also remember PBO special. PBO later oxide, because later on you will involve the heating as well. So you have to know what color salt coming out. Okay. Then zinc oxide. Zinc oxide, yellow when hot, a bit like a banana. Okay. So peanut is outside, the skin is brown color, inside yellow color. Banana, outside the skin is yellow, inside is white color. Remember? So inside is white color. I mean, this one is white. When it's cold, white color. Second, then the PbCl2 and PbI2. This one sometimes come out in objective lah. Can be tricky question like, oh, isn't it they are insoluble? Remember the chloride? Okay, chloride, isn't they are insoluble? Chloride and iodide same lah. Okay, the PbCl2, the PbI2, normally insoluble, right? Normally insoluble. But PbI2 remember is yellow color. Okay, well PbCl2 white color. Okay, so in this case, why they say soluble in hot water now? Let's say at the beginning is insoluble. Okay, let's say insoluble. But when you heat let's say when you heat, when you heat the precipitate will disappear. Precipitate will disappear. Okay, precipitate disappear. But okay, when you cool down again, the precipitate is back again, just like a magic lah. Okay, when you heat, the thing the white color thing dissolve. Okay, when you cool down, you come back again. So insoluble in cold water, soluble in hot water. So next show this. No, okay, okay. So then the other one heating how? Now heating also very simple actually heating. Okay, heating So heating what happens? Now heating normally only involve two lah. Okay, involve two So heating carbonate salt and heating nitrate salt. Okay, heating carbonate salt or heating nitrate salt. Okay, now I ask you very simple lah. Okay, so not to ask you but zinc carbonate, lead 2 carbonate, Mg carbonate when you heat only produce two things, which is now a lot of people forget this one. Okay, so zinc carbonate doesn't matter. Okay, lead 2 carbonate, Mg carbonate, calcium carbonate, copper 2 carbonate. When you heat, or even like iron 3 carbonate, when you heat, you get the oxide. Okay, we get the oxide and carbon dioxide. Okay, so and let me show this. When you heat carbonate, you come out the oxide solid and carbon dioxide gas. That's CO2. Because carbonate got CO2, definitely. Okay. They might ask okay, how to test the CO2 gas or yeah, so they won't give you direct you produce carbon dioxide. Sometimes they'll say this gas is when you bubble through the lime water turn cloudy. They give you some hint of some kind of hint to make sure you know it's carbon dioxide. Okay, you turn milky or cloudy or chalky lah. Okay, same thing. Okay, now only special one like sodium carbonate and potassium carbonate when you heat no reaction. It means you remain the same. No, nothing to come out. You remain same as sodium carbonate. Special case. Yeah, sodium and potassium. Okay. Then how about the nitrate? Nitrate, okay. Nitrate a bit different. Almost the same. You have the same the similarities. When you heat nitrate, we come out the oxide and nitrogen dioxide and oxygen. Remember, okay? Nitrate will come out nitrogen dioxide, NO2, which is the brown color gas. The brown color gas. Okay, the brown color gas. The brown color gas with a pungent smell, a bit of smelly like the spoiled fish lah. Okay, then the litmus paper turn to red color because nitrogen dioxide is an acidic gas. Okay, then the one is oxygen gas. Oxygen gas okay. So they sometimes they give you hint like lower you turn the glowing splinter is related when you insert the glowing wooden splinter into the test tube. Okay, so you produce O2. Okay, O2. Okay, and also the oxide, same thing lah. Means when you heat carbonate, produce oxide. When you heat nitrate, also you produce oxide. Okay, it just said when you heat carbonate, you produce CO2. When you heat nitrate, you produce NO2 and O2. NO2 with brown color gas. Of course CO2 and O2 are colorless gas. Okay, colorless gas. But okay, when you heat when you heat nitrate, mostly you become this one, exception, special case. When you heat NaNO3, you produce NaNO2 and O2. When you heat KNO3, you produce KNO2 and O2. Okay, so in the case is special case. This one only sometimes come out objective question, okay, a bit tricky question, that's all. Okay, in fact, I think you send the group one time. Okay, then chloride salt, no reaction when you heat. Sulfate salt also no reaction mostly, except this one. When you heat zinc sulfate, copper 2 sulfate, FeS of S4, you produce oxide and sulfur trioxide. Any question with this? No, okay. This your and this is your gas test, okay, gas test. Okay. So like carbon dioxide, I told you, you put the lime or you bubble the gas through lime water turn cloudy. Hydrogen gas, you bring the lighted wooden splinter into the test tube, you produce a pop sound. Just to remind you lah. And oxygen gas, the glowing splinter is related after you insert the wooden splinter into the test tube. Okay. So the other gas you can look through yourself. Okay, our nitrogen dioxide gas, you put the litmus paper, blue color one, turn to red color, brown color gas produce. Okay, other gas not really coming out, but you can look through yourself. Ammonia gas, okay, so it's an alkaline. Okay, it's an alkaline gas lah. Red color litmus paper turn to blue color. Okay, so any case is the chlorine gas, right? You bleach to white color. Okay, blue turn red, turn white. Okay, so the NIM test and KM test a bit later. Okay, so we move on to certain question first. Let's see which question can I do. Okay, I think we can do question 2. Okay, this one is page 17. Okay, diagram 8 shows the beaker contain a mixture of zinc salt that is given to participants during cool science challenge. Okay, competition in science week activity lah. They say they mix zinc nitrate and zinc carbonate together. State the solubility of two salt. Okay, describe how the salt can be separated, not can he separated. Okay, so zinc nitrate soluble or insoluble? How to what's solubility? Is soluble, right? Nitrate, if you see nitrate, enough already. Nitrate is soluble. Then zinc carbonate is insoluble. Then how do we separate? What process do I do? And this is also a bit tricky question. Okay. Now, since I told you that this is soluble, this is insoluble, right? Carbonate. What I should do? Let's say I seal up, I mix these two solid together. I mess up already. What should I do? Now, isn't it I can add what? I can do filtration. But how to do filtration when these two mix together? I can add water first, correct? Add water first and stir it. Add water and stir. Then isn't it surely you have one salt that is soluble, then one salt cannot soluble. If the salt cannot dissolve in water, what happen? What should you do? Filter. Yeah, you filter, then you split it. The filter one is the zinc carbonate. The water one is the zinc nitrate. Okay, so you filter and rinse the mixture. And filter and rinse. Okay, then the residue is zinc carbonate. And then the solution, the water, the liquid is zinc nitrate. That's how you split lah. Sometimes you come up with this type of question. Okay? The process is called filtration. Okay, filtration. Very simple, just like you. That's how you filter the Maggi mee with the water lah. If you want to have a dry noodle. Okay, same thing. Can I? Can I? Okay, this one. Okay, compare and contrast. No both. Okay, both sorts. Okay, when decomposed by heat. Write the chemical equation for the decomposition reaction for both sorts. How? Now, um, compare and contrast both sorts when decomposed by heat. Okay, so what are the differences? Okay, so in this case, compare and contrast means you talk about the similarities and the differences. Okay, now what is the similarities? Okay, so let's say okay, example when I heat zinc zinc carbonate, what do I get? I know. What do I get when I heat zinc carbonate? What do I get? Zinc carbonate when I heat what do I get? What the zinc carbonate we get? Two things, remember? What's the thing? Carbonate when you heat, you get zinc. Zinc what? Zinc oxide and and carbonate. What's the gas? And carbon dioxide. Okay. So and okay. When you zinc that when you heat zinc nitrate, what happen? When you heat zinc nitrate, what do you get? When you heat zinc nitrate, what do you get? Let's see. What do you get? So yes, you get zinc oxide, nitrogen dioxide, oxygen gas. Okay. So what is the common thing between them? What's the same thing between them? Both reproduce zinc oxide. The difference is so the gas are different. Okay. So how? Now, so zinc oxide, what is the color? May I know? So you can compare that. Oh, what's the color salt produce? So how? Zinc oxide. Remember the PbO and ZnO one, special salt. So what do? PbO is brown when hot, yellow when cold, like a peanut. Okay. Not to say peanut hot when hot will become what color. Okay, just the memorization. How about zinc oxide? What's the color zinc oxide? ZnO, what do you get? Like a banana, what do you get? Hot is what? Cold is what? Ah, how? So have to remember now. Yellow when hot. Remember yellow when hot, white when cold. White when cold. Okay. Now then you can say, zinc nitrate produce what? What gas? And the difference, zinc nitrate produce a brown gas. Produce a brown gas. Okay. Produce a brown gas. The NO2 that you talked about just now. Okay. When you hit zinc nitrate, you get the NO2 and the O2. Which what do is the O2 which is a colorless gas, rekindles the glowing wooden splinter. So when you put the wooden splinter inside, you get the flame going on. Okay, you relight again. Then zinc carbonate how? What gas produce? When you heat zinc carbonate, you produce CO2. Okay, which what I do is also a colorless gas, but this one is return the lump water lime water cloudy. You can say something like this. Okay. So any question is okay. Then of course lah, they want to write equation. So equation how? So the one is zinc carbonate. You heat your salt using carbonate, you get zinc oxide and CO2. Already one equation. The other equation how? Zinc nitrate heat, you get zinc oxide, nitrogen dioxide, and oxygen. The matter is you have to balance the equation. Okay, for the second one. Okay, cannot just leave it as no mark. Okay, so balance equation. Notice the O right got 6. 3 times 2, 6. 1 plus 2 plus 2, 5. Oxygen, how? What I should do? So if you found 6 and 5, even number or number, you should multiply the. If you start, you multiply the longest chemical formula, multiply 2. So zinc nitrate multiply 2. Then now your zinc oxide multiply 2. Then your N 2 times 2. 2 times 2, 4. So isn't it your N should be 4? So have to balance. Yeah, 2, 2, 4. Then your oxygen 3 times 2, 6. 6 times 2, 12. 2 plus 8 plus 2, 12. Okay? Okay, if no problem, I do the next question here. Let's see what question I can do. Okay, do one more, like question 13. Okay, I think do question 13. Which is page. Okay, this page 33. I do one more. Okay. Similar one, but do one more. Okay. So diagram 9.2 shows the flow chart of the conversion of solid X to solid Y. Okay, solution Q and gas Z. Gas Z is a colorless gas. They give you the hint on top. Colorless gas. Turn the lime water cloudy. You straight away know what gas is this. Gas Z is carbon dioxide. Okay, simple, right? You already observe all carbon dioxide gas. Okay. Then the heating of solid, they said, water also say, heating of solid X produce solid Y. Now, they said solid Y, which is brown when hot, yeah, yellow when cold. So may I know what is solid Y? Brown when hot, yellow when cold. Just now you got one, the ZNO. The one is yellow when hot, white when cold. So this one how? Brown when hot, yellow when cold. What is a solid? For X. PBO, very good. So you know P solid X, PBO. Okay. So they want to identify and do the chemical test, isn't it? Okay. So now in this case, um, what? Okay. Then we analyze what is solid Y. Now if you hit PBO, okay, you will get hit. No. Why is PBO? Sorry, the balik already. Okay. Why is PBO? No wonder I feel a bit strange. Okay. So it means what is X? Can I know what is X? When I hit X, I will get PbO and CO2. What is X? Now, I got carbon dioxide. It means what? And I got Pb. What is X? Okay, actually I got Pb. I got carbon dioxide means I got what ion? I got carbonate ion. Okay, so Pb2 plus, CO3 2 negative. So I get PbCO3, isn't it? Uh, there can also be a bit of double one. Okay, then they say PbCO3, you add nitric acid. Okay, add nitric acid. Okay, to produce solution what solution Q. Okay, so the Pb2 plus go and find nitric ion. So your solution Q is Pb and lead to nitrate. Okay, CO2 and water, which will be produced also. Okay, then the say Pb nitrate solution Q, they add into solution R. You have the yellow precipitate, and dissolve. Then they say dissolve in hot water. Okay, may I know what is this? What is this? Yellow color. Okay, but it means insoluble when it's cold, but when it is hot, when you heat, soluble. What do you get? Remember got two one, okay? The PbCl2 and PbI2, right? Instead, that one is insoluble when cold, soluble when hot, right? Correct. Okay. Now, isn't it PbCl2 is what color? PbCl2 is white color, ma. It means in this case is PbI2, which is yellow color. Okay. It means this thing is PbI2, right? I'm preparing PbI2. Okay. Now, it means what is the color solution and what is the solution R? Okay. Isn't it I have to know that PbI2 is insoluble, ma? Insoluble. So isn't it, how do I prepare? So you have to know lah. If you don't know the chemical, sometimes you have to use this method. How to prepare my salt? What is the reactant here? Okay. PbI2 is insoluble, so I need to use spun salt soluble. Okay. So I will get lead 2 nitrate. Okay. And also sodium iodide. So I already got lead 2 nitrate. So surely my solution could be sodium iodide or potassium iodide. Same thing only. Okay. Let's say I take I take potassium iodide. Then my current solution is KNO3. If I take sodium, then I take NaNO3 come out. Okay. So you can write that. Solid X is lactic carbonate, all this. Then the chemical test for gas, the carbon dioxide gas. Okay. This one, the lime water one. Okay. The lime water turn cloudy. If they ask you chemical test for carbon dioxide. Say the name for reaction one. How? What is the process name? What salt you are preparing? Soluble salt, insoluble salt. Now, if normally to prepare soluble salt, especially spa salt, okay? So prepare soluble salt, the reaction is called neutralization. Okay? So acid plus base. But for insoluble salt, what is the reaction called? What is the name of the reaction to prepare insoluble salt? They also ask one frequently. What's the name of the process? What the reaction? The answer is double decomposition reaction. Okay, very good. Okay, double decomposition reaction. Then they also have to write the chemical equation, okay, for the reaction. Okay, so you got lead 2 nitrate, which is PbNO3 2 plus um plus the Ki, right? Ki. Ki, okay. You will get, what do you get? Okay. You will get lead 2 iodide and KNO3. Pb we find I, K we find NO3. Then balance equation. NO3 got 2, right? So KNO3 times 2. Now I got 2, right? So Ki times 2. Okay lah. Okay, if no problem, right, then I move on to the cation ion and anion test already. Okay. No, no. Color and heating very simple one. Okay, color and heating just like this. Okay. Now of course the other question, no time to do it. So you can try to do yourself also lah. Okay. Um if no question, then I move on to it. Okay. Go back to the notes page. Okay. Page 12. And page 13. The ion test and cat ion test I have to explain a bit lah. Okay, explain a bit Okay. So now ion test got 4 tests. Remember the negative ion test, negatively charged ion. Okay, of course. Okay, you got negatively charged ion. Okay, that's CO3 2 negative, Cl minus, sulfate ion, and sulfate ion and nitrogen ion. Yeah, this one how to remember. Okay, they might ask one. Okay, exam. Okay, so in this part, okay, very simple one. Okay, so you got carbonate ion. Now what should do? Okay, now I tell you one more time the story, just in case you forget. Okay, now remember this one. How do we know? It means how do we know inside whether it's carbonate ion or chloride ion or sulfate ion or nitrate ion? Okay, so let's say this is my solution. Okay, now how do I know inside got carbonate? Very simple. What you should add? Only one thing. Okay, the acid, the nitric acid enough. Only the nitric acid itself is enough. Remember? Okay, the acid. Okay, here the acid. You add, okay, 2 cm of HCl. It can be HCl, it can be HNO3, can. Okay, then you come out. If they come out a gas bubble release through line water, okay, it means they coming out. If they come out, means they come out carbon dioxide. If they come out carbon dioxide, it means inside you got carbonate ion. Okay, that's simple. Okay, so the gas side, remember the turn line water cloudy lah. Okay, it means if you carbon dioxide inside you got carbonate ion. Very simple. This is the first one. The second one, how? Now, you got chloride ion. How to test chloride ion? Okay, chloride ion, you have to add acid also. Now, because you add acid to make sure inside no bubble. Okay, inside actually a bit of bubble coming out when you got carbonate ion. Because the bubble is the carbon dioxide. Okay? Now, eventually the carbon dioxide, the bubble will just float on top. You just fly out. Okay? So, but for second one, you have to add acid first. To make sure inside there's no bubble, then you add the second one. Now, because I told you chloride salt is mostly soluble. Which one is insoluble? The chloride you got, the curry one. Okay, you got Pb plus, Ag plus, Hg plus. Okay, so this one, then normally I add silver. Okay, I add silver nitrate. Okay, so the second one I add silver nitrate. Silver nitrate. Okay, now what really happen is the silver ion we go in, you dissolve the silver nitrate will dissolve. Dissolve and the silver ion we go and find the chloride ions. Okay, then you eventually form a AgCl, which is the insoluble salt, which will come out the white precipitate. So this one, okay. So nitric acid you add, okay. Then you got silver nitrate solution, white precipitate form. To prove that inside you got Cl minus. Okay. Just now carbonate ion, you only the acid, you got gas bubble coming up. Okay. This one you add HNO3, you add AgNO3, the Ag you find Cl minus to form a white precipitate. So this one, okay. Chloride ion simple, right? Chloride ion. Okay. Sulfate ion, how do it? Similar. Okay, sulfate ion similar. Okay, similar. So what should I do? Sulfate ion. Okay. I add HNO3 to make sure inside no bubble first. To confirm inside is not carbonate ion first. Then I add I ask you the same question. Sulfate is also a lot of them soluble, except what? If you got inside got Pb2 plus, Ba2 plus, and Ca2 plus, isn't it? This one remember, okay? PbBaCa, persatuan basa Cina, okay? So I should do, okay, you add barium. Add barium, okay? Now let's say I add barium nitrate, okay? Barium nitrate, okay? Now sometimes you can see barium chloride, sometimes, okay? Now, if the tricky question, they come up, you see barium chloride. So the point is not the nitrate and the chloride, the point is the barium. The barium, you go and find the barium, the barium ion Ba2 plus, you go and find the sulfate ion to form BaSO4, which is also the white precipitate. Okay, which is also the white precipitate. Okay, so same thing. Okay, this one, you got 2 same nitric acid, you add barium nitrate, you form white precipitate. So let me show you this. Yeah, so just okay, exam you just the procedure is something else. Okay, the nitric ion is the most difficult. Okay, the nitric ion a bit special. Okay, in order to test nitric ion, this okay, wait this nitric ion. Nitric ion you have to add 3 things. Okay, this nitric ion. You have to add 3 things. Okay, number 1, number 2, number 3. How do we memorize? Remember, you got 3 SO4. Remember, the SO4, SO4, SO4 Okay, so okay, the first one and the last one is H2SO4. Okay, the sulfuric acid. It's just that the first one is dilute, means quite watery one, watery. Okay. Then the other one is concentrated sulfuric acid. Very thick one. Okay. Then the other one is FeSO4, the iron 2 sulfate. Okay. The iron 2 sulfate. So you got H2SO4, dilute, FeSO4, then the concentrated H2SO4. Three things you have to add. Three things. Okay. Then what do you get? Remember, your observation is not white precipitate. Your observation is the brown color ring form. Remember, the brown ring form. This one. Okay, the brown ring form. Brown ring form. Okay. This one. Okay, on top, below. This one. Okay. So you got dilute sulfuric acid added. Of course, we have to say okay, mention 2 cm cube, 2 cm cube, 2 cm cube. But for concentrated one, you just put few drops. Few drops. Okay. Few drops because very thick. You just only add little bit only. Okay. No need to add 2 cm cube. Okay. Then you got brown ring form. You can say other part. Okay. Other procedure. Right? When you add that, okay, you add the first two, then shake well first. Then shake well first. Then you add the concentrated H2S4 slowly to the slanted test tube. You slant your test tube. Then you slant test tube, you add the concentrated H2S4, then you make it straight. Make it upright again. Then don't shake. Then you get a brown ring. Okay. This one is N9 test. Any problem with this? N9 test? No, very simple. Okay. Then what happened? Okay. So cat test. Cat test got a lot. Okay, cat test. Okay. The PB2 plus. This one I told you similar one. Okay. Remember just now I got, let's say lead 2 nitrate. I add Ki. Okay. The point is the I minus. Okay. I minus, you will go and find the PB plus. I can add an AI, Ki, can one. Okay. But the point is the I. The I will find PB plus. You form the yellow color. The yellow color PBI2. The yellow color PBI2. To form the to make sure that to confirm that inside the test tube got PB2 plus. You add 2 cm of potassium iodide. That's it. Okay. And then 4 plus you add the Nestle reagent. The Nestle one. Okay, the Milo, Nestle. Okay. You get the brown precipitate. To probe inside you got NH4 plus, the ammonium ion. This one I can go look through if you have more time. Okay. But the Fe2 plus one, you add potassium. Remember this one? Okay, potassium hexacyanoferrate 3. You remember this one? Okay. Then you got dark blue precipitate. To prove inside you got Fe2 plus. Okay, Fe plus. Okay. Potassium. Remember this one I also mentioned a bit in Form 5 Chapter 1 about the rusting of iron experiment. Okay. The potassium hexacyanoferrate 3 solution. To test the Fe2 plus one. You get the dark blue precipitate. The Fe3 plus. How do we prove inside you got Fe3 plus? You add the potassium hexacyanoferrate 2, you get dark blue precipitate. Or you can also use this, okay, the potassium thiocyanate solution. Okay, for Fe3 plus, you get the blood red solution. The blood red solution. Okay, to prove both tests are to prove inside you got Fe3 plus. Okay, and Cu plus. Cu plus means how? Now the copper ion, you add the ammonia. Okay, add ammonia. Ammonia. First, if you add ammonia, right, you form a blue precipitate. Okay, blue precipitate. Then you add excess ammonia. You add extra ammonia, excess ammonia. Then you will get dark blue solution. Means at the beginning you add ammonia, you get blue precipitate. But you add more ammonia solution, the precipitate ammonia, you just dissolve in the solution. Okay, we form all the solution. Okay, this to prove inside you got copper 2 ion. Okay, so next question is And the other part, okay, of course, Fe2 plus also I can add, not only the potassium hexacyanoferrate 3, you can add the NaOH, can add the NH3, you get green precipitate, also can. Okay, also can, okay, or Fe3 plus, not only these two, Fe3 plus not only these two, also you can add NaOH and NH3, this one you get brown precipitate. Okay, the Cu plus I talked about just now. Okay, you add energy, you get blue precipitate and dark blue solution after you add excess. The ZCM, right? Now, ZCM, okay, I have a way to memorize, in case you don't remember, in case you forget. Okay, so Z is that for zinc ion, aluminum ion for A, Pb2 plus, Ca2 plus, Mg2 plus. Remember to memorize, okay, the ZCM, first of all, remember as your zap chip small or zap cao min, whatever, okay. Then, you split, okay, you split up, then what you do? Okay, then the first one is, remember to add NaOH. Second one, you add NH3. Third one, you get Ki. Okay, this one shortcut, okay. Then what happens? Remember the WW one, okay. So W, then I split the Z and AP. W, W. Remember? Okay. Then I split the C and M. Remember the Norway, New York? Okay. And the Norway. Then they split again to get New York. Okay. Then I add all the P, right? The precipitate. Then what? Then the tick, cross, tick, cross, tick, cross, tick, cross, right? Still remember the meta? Okay. WP is white precipitate. YP is yellow precipitate. NP is no precipitate. The tick is can dissolve in the solution. The cross means cannot dissolve. Okay. So this one, okay. Like this, if I want to test zinc ion, very simple. If I test zinc ion, I need to add ammonia. I get white precipitate. Then I add excess ammonia. Okay, I need to add excess. Yeah, excess. If I add excess, then I will get dissolved in the excess ammonia. Okay. So all Ca2 plus. Okay. Or like this simple. Lead one. The lead one, you get the yellow precipitate when I add Ki. Just now, when I add Ki, I add, I will get yellow precipitate inside to prove that inside you got Pb plus. Okay, so this is a test. I need to show you this. Okay, so this is a CAM test. NH4 plus, right? Normally when add NaOH and NH3, no precipitate. Straight away just dissolve. Okay, but normally NH4 plus you can do this test. Nestle reagent, you get brown precipitate. Okay, remember if the chemical is expensive, you don't know the formula, right? You just add few drops. If you know like, oh, you know Km, then you add 2 cm cube. Okay, mostly 2 cm. If you don't know like this, you don't know how to write the formula, you just add few drops. Okay, so I need to show this. I think I do one question about this. Let's see. Okay, so let's see. Okay, look at page this one, page 16. Okay, now standard solution prepared through method 2 is used to prepare an insoluble salt, as shown in diagram 7.2. Okay, set the method used to prepare insoluble salt, just only talk about this now. Okay, the precipitation method. Normally, method is precipitation. Okay, if they ask for reaction, there will be double decomposition. But actually, these two these two, actually both can. Okay, no problem. I say the name of solution A and precipitate Y. Okay, so you got copper 2 nitrate. add into solution A. Okay. So you get a insoluble salt. Precipitate means you get insoluble salt. Okay. So it means what do you think you will get? Now, let's say I got copper. Okay, what's insoluble salt can I form? Copper. Copper I can get the carbonate. Very good. I mean not very good, but carbonate. Okay. So carbonate, copper to carbonate is the one that insoluble. Okay. Carbonate. If you remember, copper to sulfate soluble. Copper to nitrate soluble. Copper to um, nitrate sulfate, chloride, soluble. Okay, so normally the only choice is carbonate. Because copper to oxide and hydroxide is not a salt. It's a base. Okay, it's an alkali. So, carbonate. Okay, it means you want to prepare carbonate, prepare the insoluble salt, you use sponge. Okay, use soluble salt. So it's why the first reactant, the chemical you use is copper to nitrate, and so you get sodium carbonate. Okay, sodium carbonate. Okay, so instead like you get, okay, I show you the equation. Okay, so copper to nitrate, the blue color one, add into sodium carbonate, then I form copper to carbonate and sodium nitrate. Okay, it means I will get this one. Okay, then my A's, I can get sodium carbonate. Excuse me. It can be sodium, of course, it can be sodium, potassium, or ammonium. Precipitate Y should be copper 2 carbonate. Takkan you use nitrate? Okay, takkan you use nitrate to get the insoluble salt? Impossible, right? Nitrate is all soluble. So you can only think of, oh, how do I make copper to get insoluble? So you can think lah. Pair with what negative ions? Okay. You got sulfate, you got chloride, you got nitrate, all this. You got this carbonate. It means the current solution, right, is the NaNO3 lah. Okay. Then describe the chemical test to verify the presence of cation. Okay, they ask for cation in precipitate Y. So precipitate Y is the copper 2 carbonate. Okay. The cation is the positively charged ion. Remember? Cation is positively charged ion. It means they're talking about Cu 2 plus. Right? If they ask for anion, then the carbonate ion. Okay, then what do you do? Now, how to test Cu2 plus? Remember, to add ammonia. Cu2 plus is to add ammonia. Okay. Why got this one? Okay. Oh, I think they give also about the. Wait. Okay. So I think they give, if they ask for carbonate, what happen? Okay, if they ask for carbonate, okay. Let's say if they ask for carbonate and ion, also, which is the carbonate ion, then you can add nitrate acid. So the straight away you can get the colorless bubble gas can say that turn lime water cloudy. Can say something like this. Can. Okay. Then how about the Copper ion means you add the ammonia. Okay. Okay. You can either do NaOH or NH3 lah. Okay. But normally I just to memorize NH3 lah. Okay, NH3 ah. I add NH3, NH3 until excess. Few drops. I get blue precipitate. Uh, I get blue precipitate first for NH3. But if I got excess, I get dark blue solution. Now you can either focus on. Wait. I think I don't know this answer. Okay, I think I show that one. Okay. Maybe I can write this one. Okay, I propose an answer. Okay, sorry. Okay, so add a few drops. This answer not show properly. Add a few drops of ammonia solution. Okay. Then you get blue precipitate form. Okay. Then the other one is then you add lah. Okay, what happen? You add excess ammonia solution into the test tube. The blue precipitate dissolve. Can you say dissolve in excess ammonia solution to form to form dark blue solution. This one is more standard answer. You can add NaOH, but I don't recommend to confuse you lah. Okay, just remember the NH3 enough lah. So the first one is the test for carbonate ion. The other two sentences for the copper ion. Can I? No problem. Okay. So if you got no problem, okay, then um move on to the other one, page 19. Okay. Now look at E lah. Okay. Now T is thin mine that has ceased to operate. Okay. So they say lah, T is located. Okay, in agriculture area. So the water from this mine is smell pungent and not safe to drink because it contains heavy water, heavy metals, and fertilizer from agriculture as a result. Okay. So they ask they ask what is the pungent hey pungent pungent. Yes, pungent. It means you got what form? Okay. Now in this case you get ammonia gas form. I think the question is not complete. Okay, no worries. Okay. Ammonia gas form. You see pungent. Very smelly gas. Okay, and also let's say you got your lead 2 sulfate insoluble sulfate form. Okay. The point is I want to focus on the test okay, the test. Now how do you do the test Okay, for PB2 bus. Okay, you connect down PB2 bus. Okay, you put 2 cm cube. Okay. 2 you put 2.0. Okay, 2.0 cm cube of water, of mine water into the test tube. Okay, you put the first thing that you put the thing that you want to test into the test tube. Then you add 2 cm cube of potassium iodide. The Ki, you add Ki. So that the I minus, you go and find Pb2 plus. Then you have the yellow precipitate form. This is sulfate ion. I'll show you lah. Okay, sulfate ion. Um, you put also like 2.0. Okay, you put 2.0. Okay, all put 2.0. More standard answer. Okay, standard answer. Because in exam like they mark very strict one. Your teacher suddenly minus become 0 mark. Okay. So you have to write a bit proper lah. Okay. Follow the answer scheme. So 2 cm cube of mine water to the test tube same. Okay, you add, remember, now this one you add the acid first, the dilute nitric acid, then 2 cm cube of barium nitrate solution. You can add barium chloride, barium nitrate, acceptable. Just choose one. Okay, you can choose HCl or HNO3. Then you get white precipitate form. Now it's F for NH4 plus. Okay, NH4 plus. So you add the Nestle reagent. Okay, Nestle reagent. Then a brown precipitate is formed. Just remember the ion test. I think the ion test is the most difficult one. Okay, but no worries. Okay. We write down a few. I think here don't have the nitrate salt. Okay, no worries. Okay, I'm trying to find the nitrate salt. Test. Okay, done. No worries. Can I write first? Okay, done. Okay, if I ask for zinc ion, how? Let's say if I ask for zinc ion, okay, I give you an example. How to look at this thing. Okay, if you give zinc ion, very simple one. Okay, now the thing is this one. The point is one. Okay, white precipitate. Okay, so you add NH3, you get, okay, first of all you get white precipitate. After that you dissolve in excess ammonia solution. Okay, so I show you how to write. Okay, so um okay, so if I got the zinc ion test, okay, zinc ion test. So what I do is you pour, same thing lah. You pour 2.0 cm cube of, let's say this one is also your mine water lah, example lah. Okay, mine water into the test tube. Okay, then what you do is um you add 2 cm cube of What are you adding? Okay, ammonia. Okay, to same of ammonia solution into the test tube, right? Okay. Then what you get is white precipitate form. Is it white precipitate form? Okay. Then after that, what happen? After that, you will get, okay, you add excess, okay. Then you add excess and ammonia solution. You can say ammonia full ammonia solution into the test tube. Then the white precipitate will dissolve into the solution. That's it lah. That's it. Okay. The nitrate air one, okay, nitrate air one, okay, maybe I can show you. Okay. Uh, where's the empty space? No empty space. Okay, I think no already. Okay, I don't want to drag too long. Okay, for you. The nitrate air, you can look at your notes. Okay, look at your notes how to write the procedure and the observation. Okay, can revise through the notes. Okay, and try to write on your own. Okay. So the extra exercise, all this you can try to do. Any question you can WhatsApp me, ask me anything lah. If you don't understand, okay, straight away. Okay, so Uh, I see you again lah. Okay, I mean in other classes lah. Okay, bye bye. Yeah, thank you very much. Okay, welcome.